guys, it's Mariana, and for today we're going to be going over some questions from the pre-test self-assessment for IM2, and we will be reviewing turning radical form into exponential form and solving for x using radicals. Okay, so our question here is 3x squared plus 10 is equal to 19. What's our first step here? Well, actually first, before we even get to the first step, what is our goal here? Our goal here is to get this little x by himself. He wants to be a little loner, that's okay. That's okay, we respect that. So how are we gonna do that? We're gonna get rid of everything around him, right? And to be a little bit more specific, first we want to get rid of this 10, right? Because honestly, that's just really the easiest to get rid of. If we want to go ahead and divide the whole side by 3, and then that's one step at a time, So first, we're gonna subtract 10. Okay. First, we're gonna subtract 10 from both sides, because whatever you do to one side, you have to do to the other. That's gonna leave us with 3x squared plus nothing, because we got rid of that 10, is equal to 9. Yup. Okay, so x is still feeling a little uncomfortable with this 3 right here next to him, so we're gonna get rid of him too. So we're gonna divide 3 by both sides, because the opposite of multiplying is dividing, right? The opposite is dividing. So if we're multiplying x by 3, we're gonna divide by both sides by 3, and that'll leave us with x squared is equal to 3. But oh no, guys, I'm sorry, let me not be this dramatic. Okay, there's still this little x squared here, and x is not liking that, and neither am I. So what we're gonna do here is we're gonna get ready for it, guys. Get ready. We're gonna square root this, and we're gonna square root both sides. I know you're shocked. I know you're super shocked, right? Just play along. Okay, so when we square root something that's being squared, it literally cancels this whole thing out, which makes it just x, right? Because the inverse of square rooting, the inverse of squaring is the same thing as square rooting. Mind blown. So now we are just left with x to the square root of 3. Now we can actually get a little bit more specific and say plus or minus the square root. Because actually, let me pull my calculator so I can tell you the exact number. Okay, so you're gonna get something out 1.7 something. We really don't care. What I want you guys to understand is that whenever we square root something, we can get out either a negative or a positive. And the reason for this is because, let's say for example, square root of 9, right? Square root of 9 we know is 3, but it can also be negative 3, right? Because if we were to do negative 3 squared, we'd also get 9, because negative 3 times negative 3, a negative times a negative is a positive, so that's just gonna cancel out and give us 9. So if you wanted to be super specific, you could say plus or minus square root of 3, which is just the positive of whatever this value is, or the negative. But we actually don't need any of this, and we can just leave it right at that. And that's what x is. It's really just doing the inverse to be able to get x all by itself. So let's move on to the next question. Wait. Next question, our question here. Once again, our goal for this question is to get x all by its lonesome. X is happiest when it's by itself, I guess. Anyways, so here we have 1/3 times x minus 1 to the power of 3 is equal to 9. So first up, this is like a really funky equation, but we're going to take it one step at a time. So the first thing and the most obvious thing that we can remove is this times 1/3. So if we are multiplying by a fraction, right, we can multiply by its reciprocal. And reciprocal just means like it flipped over. That's like the way I like to think of it. You just flip over whatever this guy is, and if we were to flip him over, we get 3/1. And the reason that works is because look, if we do 1/3 times 3/1, we get 3/3, which is just 1. And anything times 1 is just itself. So what I'm going to do is I'm going to multiply both sides by 3. And then we should get x minus 1 to the 3rd power is equal to 27. Okay, so we're getting closer. We're kind of getting there, right? But we're still not done. So what I'm going to do is, the way I'm going to get rid of this to the 3rd power is I'm going to cube root it. What? You can do that? Yes, you can do that, guys. I don't know if that's really obvious to you, but when I was doing this for the first time, I was like, I had no clue we could do that. So we're gonna, like, what this literally does is this cancels out both these little things right here. And it's really like the same idea that, okay, here's something I don't know if I clarified. X squared is the same thing as like, right? It's just usually we don't use this too because there's kind of like an assumption that this is the square root, right? Squared. Do you see that? We are square rooting. We're gonna square this number. Yeah. So if we are cubing something, we're gonna cube root. Hey, do you see where I'm getting at? Yeah. So, okay, now that I clarified that, we know that the way to get rid of this cubing, sorry, I don't know why it wasn't coming out. Okay, the way to get rid of this cubing is by cube rooting. So what we do to one side, we have to do to the other. Okay, and now we can rewrite this as x minus 1 is equal to 3 because the cube root of 27 is 3. And if you're curious, the reason this time we don't have like 3 and -3 as our answers for the root, it's because, it works if it's all a positive, right? Because 3 times 3 times 3 is 27. But if we were to say that the cube root of 27 is -3, that actually would be incorrect. Because -3 times -3 times -3, these cancel out, right? So that makes a positive. But then there's this negative right here, which means our answer would end up being negative. And what we want is a positive 27. So that's just clarifying why we get out only positive 3 and not -3. So now, this might look a tad bit familiar. I kind of hope it does look familiar. We're just going to add 1 to both sides to get x by itself. And x is equal to 4. Bam, we got that done. Okay guys, so for this question, what we want to do is that we want to turn this right here into I'm not even going to write it out, just know it's exponential form. So we want to get this to be x to the a over b power. Right? That's what we ultimately want to get that to. But I bet you guys can already see that this guy is looking a little bit funky compared to our other equations. So what I'm actually going to do is I'm just going to ignore all of this, like on the outside for now. Like I just don't want to look at that right now. I'm going to focus on everything that's in the parentheses. So let me just rewrite this real quick. And the reason I'm doing this is just so it can, for me, it's a little bit more doable if I do it in this way. I'm going to firstly focus on these little guys inside. So this guy, using our rules that we have right here, x to the a over b is the same thing as the b root of x to the a power. This right here is our a, this is our b, and this is our x. So this would mean if we want to change this little guy to radical form, we would have the b root, so in this case b is 5. And then in this case our x is a. I know that seems a little complicated, but yeah, our x is a, and our a right here, this little guy right here, is 3. So gee, why did I write b right here? Our b is 5, so sorry. Yeah, and you can see that because that corresponds with that. Is our a, so our 3 is going to be right there, and our 5 is our b, so it's going to be the 5th root. So we just transformed this into this, right? Now we want to transform this little guy right here. So just remember, we're going to use this little like rule right here. X to the a over b power is the same thing as saying the b root of x to the a power. And this, for this one, our x is b. So I'm just going to write b inside the radical. And then our 5 is what our root is going to be by. So it's going to be a 5th root. And then this 4 right here is going to be what our x value in this case is being like to the power of. So this b is going to be to the power of 4, right? And really all we're just using is using this little rule right here. Like all you need to remember is how this rule works. Like if I were to tell you to memorize one thing, it would be all of this right here. So now we have the 5th root of a to the 3rd power times b to the 4th power by the 5th root, right? And then obviously we have those parentheses, and let's not forget up here we have that all squared. But we can actually simplify like all of this a lot simpler, right? Since they're both to the 5th root, we can just rewrite this as the 5th root of a to the 3rd power times b to the 4th power, right? So we have that, and now I'm just gonna leave it at that, and just don't forget my little squared right here. And this is just what we're left with. Yeah, so then at the end we were left with the 5th root of a to the 3rd times b to the 4th, and then all of this was squared. Now, here's one more extra step. So, if you remember, right here, this is our exponent, right? So, we can actually write that as saying 5th root to a to the 3rd, 8 cubed times b to the 4th power. All of that would be the 5th root of a to the 3rd times b to the 4th, and that is all squared. But we can actually go a little step further, because if you remember from these little rules right here, this like technically has a b value and has a b value of 1, right? So this one is going to go to the outside, and the a value is going to go to the inside. So if we like simplify this even more, bringing that 1 over there to the 5, it's just going to stay as a 5, right? 5 times 1 is 5. And then we're going to do 8 to the 3rd power times b to the 4th, and then this is all going to be squared, right? And if we square that, this is the same thing as just multiplying. So for example, if we have x squared to the power of 2, it's just going to be x to the 4th. We multiply these exponents, so it's going to be the 5th root of a to the 6th times b to the 8th. There we go. That is the final answer for this one. And really all we were just using was these little rules over here. So just don't forget that we can actually break this down into little parts, and each time we just go back to using these little set of rules over here.